Welcome once again to Animaths. We are going to take up a 9th standard topic today, and I am Anandita. So, this is 9th standard, this is from 9th standard geometry. In 9th standard geometry, we are going to take up the topic circles. Okay, so we are going to take up chord properties of circles today. Chord properties of circles. So first I shall be explaining what chord property is, and then we shall be taking up few questions on chord properties. Okay, so let's see. Now here we talk about, if I have a circle here, okay, let's assume we have a circle here, and in this circle, this line, a line joining 2 points on the circumference, is called a chord. You all know it. So the biggest chord of a circle is the dia. Okay, I am not drawing it here, but the chord which will pass through the center and join the circumference, okay, if I join it from here to here, it will be called the diameter. Okay, so this is the chord this is the chord of a circle, and here is the center. Now what does the chord property say? In chord properties, they say that if a line is coming from the center perpendicular to the chord, that is, first condition it is coming from the center, second condition it is coming perpendicular, then it definitely bisects the chord. Okay, so in geometry you have to be very clear about what is given and what is, coming as a result. So given here is coming from the center and perpendicular to the chord, and result is, as a result we are bisecting the chord. Okay, so this is the chord property of a circle. Now we can do one thing, we can even prove it. Why should we just believe what they are saying? Okay, let us prove it. So how do we prove it? If supposing we join the radii, this is the radius, okay, and here I get two right angled triangles. So OAB, let me take it as X. Then if I take these two triangles, OX is equal to XO, because that's the common one. Okay, if OX is equal to XO, then let me take angle OXA is equal to angle OXB, because they are that is given. So this is equal, this is 90 degree. This one is equal to this, that is OA is equal to OB. This comes with a very simple proof of congruence, because this is the radius. Both are radius of the same circle, so they are equal. Therefore, triangle OAX is equal to triangle OBX is congruent to triangle OBX. Okay, so hence we have proved congruence between these two triangles. By what? By right angle hypotenuse side, by R, H and S. Okay, so we have proved congruence. Now once we have proved congruence between these two, we can always go for one more step ahead, and that is, what is it? So one step ahead we will go, that is AX is equal to XP. Why? Because of CP CT, right? So because now this becomes equal to this because of CP CT. Okay, so what did we do? Since it was given this is perpendicular and it is coming from the center, therefore we could prove congruence between these two triangles, and finally we could say AX is equal to XP by CP CT. Okay, now let me take up the opposite of this. Now the opposite of it is also true, which says that if a line is bisecting the chord from the center, then it must be a 90 degrees. Okay, a line bisecting a chord from the center is bisecting it at 90 degrees. Okay, so here let me redraw this figure, and I will redo this proof also. So this time let's see what is given and what is to prove. So here we have, this is a circle, and here we have the center back again, and we have the chord AB. Okay, if we have the chord AB, this is the line from the center. This time we are not going to take it as a perpendicular and we are going to join the radius as usual. But then what is given this time? The line bisects the chord. So this is equal to this. That is given. Okay, if this is equal to this, now we have to prove these two angles are 90 degrees. How do we prove it? Okay, so we have to prove that the two angles are 90 degrees. So how do we prove it? So we start with OA. We start with OA is equal to OB, yes, and then OX is equal to XO, that is common, and AX is equal to XP, okay, AX is also equal to XP. With these three things, now we can say triangle OXA is congruent to triangle OXB by what? By triangle OXA is congruent to triangle OXB by SSS. This is equal to this, this is equal to this, and this one is common, so it is equal by SSS. Therefore, angle OXA is equal to angle OXB by what? By, so these two are equal by CPCT. Once congruence has been proved, we can always say by CPCT these two are equal. Therefore, if this angle is an X, this is also an X. So can we not write X plus X is 180 degrees because it is a straight line, chord is a straight line, right? If chord is a straight line, 2X is equal to 180 degrees, X is equal to 90 degrees. Okay, X is equal to 90 degrees. Therefore, we have proved that this line OX is perpendicular. OX is perpendicular to AB. We have proved it. Okay. So, this was, I have proved it in two different ways. Okay. I proved it in two different ways. Once from, I proved it once from this is perpendicular, then it bisects, then the other one was it is bisecting and therefore it is perpendicular. Okay, so we'll do some sums on this. Now here is a sum which is telling us if there is a circle which has two parallel chords. Now they only have told us that the two chords are parallel, which are two parallel chords, and in the two parallel chords the radius of the circle is 5 centimeter. And the two parallel, find the distance between the chords if they are on the same side of the center or on different sides of the center. So here it is, let me first draw, see how the sum changes if the two chords are on the same side of the center or the two chords are on different sides. See, okay, this is the figure for the two parallel chords to be on the same side of the center. This is the figure for the two parallel chords on different sides of the center. See, okay. So these two are parallel and these two are parallel, but these two, the difference is these two are on the same side, these two are on opposite sides. This is a very important question, and in this question they will ask what is the distance between the chords. Now you can clearly see in this the distance is much less, and in this the distance is much more. Okay, so how to solve this sum? Here, note this, if I join it here, see, note that these two are parallel. So if I make a line which is at 90 degree to this, naturally this angle will also be at 90 degree because these two are parallel. Okay, so we can say yes, the same line is going perpendicular to both the chords. Here also I can make one line parallel, one line perpendicular to this, and it will also go perpendicular because co-interior angles have to be supplementary because they are parallel. Okay, so I'll just make this straight. This is not looking parallel. Yes. Now the thing is, I will join the radius. Okay, here I'm joining the two radius. Let me concentrate on this one first. Okay, let me concentrate on this diagram first. Now here is the center O. The radius is 5. The length of this is 6 and the length of this is 8. Now if a line is going from the center and going perpendicular to the two chords, then it is bisecting the chords we just learned from the theorem we explained before this. So now we are having, this is, if this full length is 8, this length, that is, let me name it, this is A, B, C, D, and let me name it as X, and this is Y. Then XB is a 4 because full length was 8. Okay, here YD is a 3 because full length was a 6. Be careful to when you name them. Now here, this, if I go for this triangle XBO, then this is 5, this is 4. If I apply Pythagoras, then 5 square is equal to 4 square plus OX square. Yes, and OX square comes as a 25 minus 16, which is a 9. OX comes as a 3, right? OX is a 3. Okay, if OX is a 3, and then let me talk about OY now. Okay, if what is OY then? So for OY, it is, for OY I have, let me take the triangle YDO. Okay, let me take the triangle YDO, and in this triangle I will tell you, this is YD is 3, so 3 square plus YO square, yeah, YO square, this length, we are taking this triangle YDO. Okay, and YO square is equal to again 5 square because this is the radius, OD is the radius, 5 square. YO square is 25 minus 9, which is 16. So YO is equal to 4. Yes. So I have the value of YO here, I have the value of OX here. So this is 4, this is 3. Therefore, this distance becomes a 1. Distance between the two chords becomes 1. Let me come to this. This is the smaller one, so this is 3 and this is 3 because line has come from the center and perpendicular, so it will bisect. Here this is 4, this is 4. Diagram is redrawn and you see the difference in diagram in both cases. This is a 5, they have told, this is also a 5. 5, 4, and this is how much? This is the X here and here is the Y. This is the CD and this is the AB, right? So now here, if this is 5, this is 4, if I apply OX square is 25 minus 16, I am using Pythagoras, then I get a 9, OX comes to a 3. Here also OX was a 3. So this length is a 3. If I apply Pythagoras here, then 25 minus 9 is OY square. OY is a 16. So OY square is a 16. OY is a 4, right? OY is a 4. So this length is a 4. So now the distance between the two of them, the distance between the two, that is XY length, has become 7. Yes, isn't it? And here XY length was how much? Here XY was clearly a 1. Yes. So this is the difference between the two. So you have to read the question clearly, and if the question says on the same side of the chord, go for it. If the question says on different sides of the chord, then also draw the diagram accordingly. And sometimes, like this question, they will say on both sides of the center. The chords are on both sides of the center. So when they say on both sides of the center, you should draw two diagrams like this. If they say only on one side of the center, draw this. If they say on opposite sides of the center, then you can draw this. Both sides, you have to draw both, and in that case you will get two answers. Okay. Now here is the question. O is the center of a circle and AB and CD intersect at P such that PO bisects BPD. Okay, let me draw the circle only, because as long as I don't draw the circle, it doesn't mean anything. So here O is the center, and AB and CD are two chords which are intersecting at a point P. This is the point P. Okay, and here goes the 90-degree line. Here is the 90-degree. Okay, 1 minute. They haven't talked about the 90-degree line, so I will also not draw it now. So It has become my habit to draw that, but since they haven't talked about the 90-degree line such that PO bisects angle BPD. Now PO is a straight line which is bisecting this angle. That much only is given in the question. Prove that AB is equal to CD. Now this is AB and this is CD. This is the question. Prove that AB is equal to CD. Now how do we prove it? Now here we'll have to make some construction, that we'll have to make this. Okay, we'll make this, that is the line from the center which is at 90 degrees. Line from the center at 90 degrees. Done. Okay, such that now we'll start with a sum. Now the triangle that, let me name it as F and this as E. Now I have two triangles, OPF and OPE. Let us concentrate on these two triangles only. Rest we'll forget for the time being. Angle, this angle OPE, angle OPE is equal to angle OPF. Now why is it so? Why is angle OPE is equal to angle OPF? Because they have told bisects. That is why. Okay, angle OFP is equal to angle OEP. Okay, and OP is equal to OP. OP is equal to OP. This is the common side. Therefore, triangle OPF is congruent to triangle OPE. By which one? By what is the, by which postulate is it congruent? It is congruent by angle side. Now if you are having difficulty in understanding congruence, because I am straight away writing AS, go back and check my videos on congruence. Okay, so you will be able to understand. This is a very simple question on congruence. There are 4 postulates in congruence. So if you have two angles and one side equal, then we write AAS. Okay, now we have congruence ready with us. So these two triangles are congruent. So we can therefore say OF is equal to OE. That is, the two lines that we had constructed are equal. Why are they equal? They are corresponding parts of congruent triangles. By CPCT they are equal. AB is equal to CD. Therefore, why is AB is equal to CD? Straight we can write AB is equal to CD. Why? Because if a chord is equidistant from the center, if a chord is equidistant from the center, then they are equal. Similarly, two equal chords are equidistant from the center, and this line is nothing but the distance of the chord from the center. Remember, any 90-degree line, any perpendicular line always gives the distance. Therefore, it's not that this can't work as the distance. The line which is showing the distance is only OF or OE. OF is the distance for CD from the center. AB is for AB, the distance from the center is OE. Only the line which is perpendicular will give you the distance from the center. So this is the distance from the center. So AB is equal to CD. Why do we come straight to that? Because they are equidistant. That is their distance from the center. They are equidistant from the center. They are equidistant from the center. Therefore, these two are equal. AB is equal to CD because they are equidistant from the center. Okay, so this is our next sum. There are two circles they have told, and their centers is at A and B, and they meet internally. They have told they meet internally. So this is how they meet. This is how two circles meet internally. And the line between their centers AB, PQ is the perpendicular bisector of AB. That means it is 90 degree also, and it is bisecting AB also. Okay, the radius of the bigger one is a 5 and the radius of the smaller one is a 3. So the radius of the bigger one is a 5 and the radius of the smaller one is a 3. Now I have drawn the radius of the bigger one. Now what mistake people do is they will generally draw, if the radius is given, they don't understand that we have to make use of the radius. Okay, they will draw the radius here, they'll draw the radius here, they'll draw the radius here. They don't draw it at the right place so that it makes a triangle. So they have to draw it here so that it makes a triangle. Okay, now this is 90 degrees and this part is equal to the other part. Let me now try out what they are asking for. They are asking for the length of PQ. So if I take here to here as an x, okay, let me name it as an O, OP as an x. Then if OP is an x, x square plus how much do I take as AO? That is the big question. Here A to the end here is a 5 because the radius is 5. B to the end, I am not drawing it because if I draw it, it will add to the confusion. A till the end radius is 5. B till the end, because that is the radius of the smaller circle, is 3. Then AB is a 2. AB is a 2. That AB has been bisected, so AO is a 1. Okay, therefore x square plus 1 square, the 90 degrees here, and this is the hypotenuse. AP is the hypotenuse, is 5 square. X square is 25 minus 1, which is a 24. So x is root 24. Okay, you don't have to panic for this. Numbers can come like this, no problem. Then how much is PQ? Now remember, this is a line, AO is a line which is going perpendicular to PQ, and that is a chord, and this is the center of the circle. A is the center of the circle. So it is going from the center to the chord at 90 degrees. Therefore, PO is equal to OQ, right? PO is equal to OQ. If PO is equal to OQ, therefore, then if PO is equal to OQ, then what happens? If we want full length of PQ, PQ is equal to twice and 2 times root 24. Now you can write the answer like this, but you can also write the answer like this, 4 into 6, which is 2 into 2 root 6, which is 4 root 6, isn't it? So that's the 4 root 6, which is 4 root 6 centimeters, because everything was in centimeters. So this is 4 root 6 centimeter, because this was in centimeter, 3 was in centimeter, so this was in centimeter, hence your final answer is 4 root 6 centimeter. So the length of the chord, full length of the chord PQ is 4 root 6 centimeters. Okay. So this is one of the very tough questions, and remember, this sum cannot be done in a hurry. This sum cannot be done straight in the examination hall also. This sum has to be practiced before, few times beforehand, if you want to get it in the exam. Okay. So this is the next question. BC is the diameter of a circle. Okay. So let me take BC as the diameter of a circle with center O. So O is here. And AB and CD are two chords such that AB is parallel to CD. Prove that AB is equal to CD. Okay, so here AB is parallel to CD. Prove that AB is equal to CD. We have to prove these two lengths are equal. How do we prove it? Okay, since this is parallel, we can make our construction here, that is a line coming perpendicular from the, if you have drawn it perpendicular to this from the center, you have to draw this also perpendicular. Automatically, it's not that I am making it perpendicular to this and I am also making it no. If this is perpendicular, the straight line, if you extend, it will finally be perpendicular because the two lines are parallel. Why? Because sum of these two angles should always be a 180. Therefore, if this is 90, this automatically becomes 90 if your line is a straight line. Okay, so this is the construction that we do in the figure. Now, I have a triangle here and I have a triangle here. Now they have told two chords. Okay, they haven't told that they are equal. So we can't assume they are equal. Okay, we can assume this is equal to this part. This angle is equal to this angle, because if this is 90, this is also 90. And this angle is equal to this angle. That much we can assume. Okay, so we can say that these two parts are you know, this angle equal to this is alternate angles because lines are parallel, this is equal to this because we have already drawn straight line from the center, okay, and then we can say yes, this OB is equal to OC. So let me write OB is equal to OC, radius, angle, let ABO is equal to angle DCO, okay, is equal to angle DCO, and next is angle, this is because of alternate angles. Now let me name it as an X. Without naming, I am not being able to do it. BXO, that is this 90 degree, is equal to angle CYO. Okay. So I have talked about the two angles, alternate angles given, and this is radius. Therefore, triangle BXO is congruent to triangle CYO. Okay, by what? By angle side property, by angle side postulate. If it is so, by angle side postulate, then I can say that OX is equal to OY. Why? By CPCT, corresponding parts of congruent triangles. My very next line after this, I can straight away write AB is equal to how much? AB is equal to CD. Why can I write it straight like that? I can write it straight away like that because AB is equal to CD. Why is AB is equal to CD? Because the distances of the chords from the centers are equal. So OX was the distance from the center and OY was also the distance from the center. Hence AB is equal to CD. Okay, because equidistant chords are equal. Now this is again, it comes as a small theorem in this chapter where they say if the chords are equidistant, that is at equal distances from the center, they will be equal. And another one what they say is if the chords are equal, they are definitely going to be equidistant from the center. So with the help of that theorem, we finally prove since this part is equal to this, the two chords are definitely equal. Okay. Okay. So this is our next sum, two equal circles, that is the circles are equal means they have the same radius, okay, intersect at P and Q, that is they have intersected over here, okay, and a straight line through P means this is a 180 degree, this angle is a 180 degree, it is a straight line meets the two circles at A and B, you have to prove QA is equal to QB, okay. So the very first thing I want to tell you is if I have a circle, this is also coming from a theorem. Since you don't have theorems in your portions, I am not making videos on that. If this arc is equal, okay, then if this arc is equal to this arc, let's say, then the chords that they make in the equal circles, in same circle or in equal sized circles, are equal. That means, I repeat, if this arc is equal to this arc and if the circle is same or the two circles are equal, then this chord will be equal to this. Second thing, equal chords will subtend equal angles or even equal arcs will subtend equal angles if the circle is same, okay, not if the circle is of different size. So since the circle is same, and here also we assume the two circles to be same only. Why are the two circles same? Because they have the radius same, so they are equal circles, so we assume them to be same circle. So this equal arc is subtending this angle, this equal arc is subtending this angle, hence the two angles are always equal. We are going to use this concept over here. They are the same circle. Why are they same circle? Because they are equal circles, okay. And in equal circles, see, this is a common chord. PQ is a common chord. PQ is a common chord means the arcs are equal because the circle size is same. If the chord size is same, the arc size is same. Okay, and the arc, let me name it as let's say D and C. So PDQ, PCQ, these two arcs are equal. So if PDQ is equal, this angle to PCQ, these two angles will be the same. Okay, so let us now proceed with the sum, how to write it, because sometimes students don't understand how to write it. PQ is a common chord, so it's an equal chord, right? Therefore arc PDQ, okay, remember you name a arc with 3 letters just like an angle. Arc PCQ, okay, this is what you put for an arc. Okay, so these two arcs are equal. Then angle QAP is equal to angle QBP, because equal arcs subtend equal angles if the circle is same or if the circles are equal. Okay, therefore triangle ABQ is an isosceles triangle. Why? Because it is an isosceles triangle. Why? Because base angles are equal. Therefore we can say that QA is equal to QB, because in an isosceles triangle, if the base angles are equal, the opposite sides, opposite to this is QA, opposite to this is QB, that is also going to be equal. Hence this is QA is equal to QB. Hence we have proved it. Okay, so the only thing we have to know is equal arcs subtend equal angles if the circle is same. Okay, or even equal chords also subtend equal angles. Okay, so this was it from the whole chapter of chord properties. There are many more sums, but I have picked up the most important questions from this chapter. Okay, the ones you might find it very difficult. Okay, so the next video that I am going to upload is angle properties of a circle. Okay, so that is also part of this chapter, part of circles only. Here we have talked about only chords and angles subtended by a chord, but after this we are going to talk about few more, how angles become equal in a circle, when angles become equal in a circle, and all that. So circles chapter will come in 3 videos. One is chord properties, next is angle properties, and the third one is going to be all sums on cyclic quadrilaterals. Okay, so that is it. If you have liked the video and you have found it useful, do not forget to like, share and subscribe, because there's going to be lots of important question papers also coming up. And if you have any problems, you can always put it down in the comments section. Your comments and your difficulties and your doubts are most welcome. So if you have a doubt in my video also, you can comment about it and I'll try to solve it in the next video, or I will be giving you the answer in the comment section itself. Okay then, bye all of you.